Day 6. And more factoring. Yay. I want to highlight 6. Day 6. More factoring. Yay. Uh-oh. Wait. Got to read the directions. Round to the nearest minute. And look. Strictly less than 360. Ooh. That's going to be weird. All right. We're going to get to the nearest minute. If we have to round, it's to the nearest minute. So let's see how we do this. What are we going to do here? By the way, if you haven't hit the subscribe button, if you haven't hit the like button, and if you haven't hit the I love Mr. Kraus button, do it now. I said now. Ooh, good accent. Anyway, GCF kids, take out the sign. Sine of theta. That's going to be the easiest one on the test, and yet probably one of the most missed. Sine theta minus 1. Don't forget, you need a placeholder. Even if you take out everything, there's still a little 1 here. All right. Wow, the hard part's over. So sine of theta equals goose egg, and sine of theta equals 1. Well, anytime there's 0 or 1, I want you to draw that quick sketch of that sine curve like this. And it's at 0, 180, and 360, and it's at 1 at 90. So those are my answers. Wait a second, I can't use 360 because it said strictly less than. So we're not able to add 360 in. So my answers are 0, 90, and 180 degrees. Woo! Mr. Krabs, math rocks. It's a rock and roll. How about we cross multiply? I would just multiply both sides by 2. So I get 2 sine theta equals 3 sine squared theta. Anytime there's a squared, even when we're dealing with trig, we want to make this equal to 0. So we'll do 0 is equal to 3 sine squared theta minus 2 sine theta. Take out the GCF. In this case, the GCF is sine of theta. And we're left with 3 sine theta minus 2. Uh-oh, mailman's here. Dogs will let me know that the mailman's here. All right, so this one's easy. It's just sine of theta equals 0. And that's this drawing again. 0, 180, normally 360, but we said less than 360, so we can't use it. And then we end up with sine theta equals, bring the 2 over, divide by 3, 2/3. So this one I don't know. It's not radical 2 over 2. It's not square root of 3 over 2. It's nothing I know. So we will have to go to the calculator. And we'll do inverse. That's interesting. We'll do inverse sine of 2 divided by 3. And I get 41, but I got to DMS it. So I go into math there, and I DMS it, and it's 41 degrees, 49 minutes. 41 degrees, 49 minutes. Remember, 30 is the cutoff. So now here comes the hard part. The hard part is this. First of all, sine is positive in the first and second quadrant. First and second quadrant. So this will be an angle I have to keep because I want the positive. And then I got to get the angle in the second quadrant. Remember, that's coming back from 180 degrees. So what we're going to do is we're going to take 180 and we're going to subtract this. And it's going to give it to me in decimals, so I got to DMS it again. $138.11. So my other answer is, I don't need this. So 138 degrees, 11 minutes. So my final answers are 0 and 90 for this one, or excuse me, 0 and 180 for this one, 41 degrees, 49 minutes for that one, and 138 degrees, 11 minutes for this one. That was fun. What number was that? 3. There's 5. We'll go to 5 next. That's weird. Oh, just different directions. So let me get 5 up here. Get lots of room, lots of space. So we're going to factor it. Oh, maybe I should bring the 3 over first. Okay, so let me bring the 3 over. Minus 3 equals 0. So let's factor this sucker. Factoring's not too bad. I'm pretty sure it's going to be 4 sine theta and sine theta. And then plus 1 and minus 3. I believe that's the factoring. Or excuse me, plus 3 and minus 1. All right, set them equal to 0. So 4 sine theta plus 3 equals 0. This just gives me sine theta equals negative 3/4. Now, negative means I'm going to be in these two quadrants. So this one's going to be a little bit trickier. A little bit tricky. I'll explain exactly what we need to do. And this one is just sine theta equals 1. And I know sine theta equals 1 at 90 degrees. So this one's just going to give me 90 degrees. This one's a little bit trickier. Now, remember what I said yesterday. We're not going to put in this negative. We're not putting in this negative. We're just going to put in the 3/4 because that will give us the reference angle. So we come over here, and I'm going to do, and this is really important. Don't think you're not going to be able to. Don't think you're going to be able to do this or not do this. You have to do this. Divided by 3 divided by 4. Wasn't it 3 divided by 4? And yep, but I don't want that one. I want the one in this quadrant. Now, I'm not going to DMS it yet. I'm going to DMS it at the end. So I'm going to take 180 degrees and I'm going to add this thing. So I want to add 180 degrees to this. And that's the angle I want. So that's the angle I'm going to DMS. So here are my answers so far. 90 degrees. Now this one's 200 and something. 228 degrees, 30. It's only 25, so we're not going to round that. So 35 minutes. Now I want the angle in the 4th quadrant. So I got to take 360 and subtract off that 48 degrees. So I'm going to take 360 and I'm going to subtract off this. And I get, oh, I got to DMS that. 311. Now look at that. 34 is going to round that to 25. So 311, 25. 311 degrees, 25 minutes. There it is. Moving on to number 7. All right, let's see. Now, oh, again, we're still not using 360. So let's see what we got here. Bring the 1 over. So I get 2 sine squared. I got 2 s's. You'll get over it. Equals 1. So now I'm going to do sine squared theta equals 1 over 2. Take the square root of both sides. And I get sine squared theta equals plus or minus the square root of 1/2, which is really the 1 over the square root of 2, which is really square root of 2 over 2. I took the square root. So sine theta equals the square root of 2 over 2 plus or minus. And because it's plus or minus, that means I'm going to have 4 answers. 4 answers. And that means 1 in every quadrant. And again, 45 degrees in every quadrant. Hopefully I have 45, 135, 225, and 315. So 45, 135, 225, and 315 degrees. All right, going off to number 9. Again, not using 360, and this time we're rounding to the nearest degree so we don't have to DMS anything. Didn't I already do one like this? No. I didn't. So, probably 4 sine theta minus 1 plus 3. I thought I did one like this already. Oh, plus 1. I'm sorry. Oh, no. Okay, we're good. We're in good shape. Plus 1. All right, so this would give me negative 4 and positive 1. Okay, so this one gives me sine of theta equals negative 1/4. And this one gives me sine of theta equals 1. Well, this one's easy. It's just 90 degrees. No problem there. But this one, remember, we're not going to put in the negative. We just got to figure out what our reference angle is. So I want to figure out what my reference angle is. Come over to my calculator, and I'm going to do inverse sine of 1/4. Could have put it in 0.25 if I wanted. And to the nearest degree, that's 14 degrees. But I need to be in where sine is negative. That's down here and down here. So I'm going to take 180 and add it. So 90 degrees, we'll start with that. And then I add 180 to 14, I get 194 degrees. And I subtract from 360, and I get 346 degrees. Moving on. Round to the nearest minute. Notice the directions are changing for all these, but we're not including 360 again. Well, sometimes they include it and sometimes they don't. So first thing I got to do is I have to get all of it over. It's just like a regular old quadratic. You got to get the squares and all the terms over. Sine squared theta plus 4 sine theta minus 1 equals 0. Five sine theta. It's got to be 1 and 1. We want positive 4, so we'll put the plus here and the minus here. Okay, so this one gives me sine theta equals 1/5. That's positive. Positives in quadrant 1 and quadrant 2. This one gives me sine theta equals negative 1. And again, remember the graph. It's equal to negative 1 at 270 degrees. So in this case, theta equals 270 degrees. This one's a little trickier. Not much. Just got to get, well, I'm just going to use that same thing, except in this case it's 1/5. And we got to round to the nearest minute. Now, is this one I want to keep? Well, this is going to give me 11 degrees. It's in the first quadrant. So yeah, this is going to be one I want. So I know it's 11 degrees something. 11 degrees, and I got to get it to the round to the nearest minute. So I'm going to DMS it. And it's 11 degrees, 32 minutes. Now I need to get in the second quadrant. So that means we're going to take 180 and we're going to go backwards. We're going to subtract. So 180 minus this 11 degrees. And we'll immediately DMS it. It should be somewhere around 168 something. 168. Now notice this is 46. The cutoff is 30. So 168 degrees, 28 minutes. And find 70 degrees. Where's 13? That's 11. That's 12. Oh, all right. So this is actually number 13 right here. It says 14, but it's actually number 13. All right, we're ready to graph. We're ready to factor. So sine theta plus 5 sine theta minus 1. So this one gives me sine theta equals negative 1, which we reject right away because sine and cosine can't be bigger than 1 or negative 1. And then sine well, that's a bummer. Let me pause this then. All right, I think I got us close to back where we were. That one we have to check because it can't be bigger than 5 or smaller than -5. You know, as long as its absolute value is bigger than 1, we got problems. This one gives me sine theta equals 1, and we know sine theta equals 1 at 90 degrees. Done. Problem's over with. We're done with that page. Let's get to the next page. Number 15. That's a squared. Oh my God, this vectoring is so difficult. I can't do it. Let's see. 18. All right. Sine squared theta minus 27 sine theta plus 10 equals 0. So this is going to be, what are we going to use? 6. We can either use 6 and 3. Let's try 6 and 3. 6 sine theta, 3 sine theta. I'm guessing this is 5 and 2. So if I put a 5 here and a 2 here, that's not going to work. That's not going to work because I put the 2 here. That does give me 30, but this gives me 6, so that's not going to work. Let's switch them. Switch them's going to work. Let's see. 5 here. They both got to be negative. And 2 here. That's 12. Oh, 12 and 15. There it is right there. 12 and 15. All right, great. So this one ends up being sine of theta is equal to positive 5 over 6. And this one ends up being sine of theta equals positive 2 over 3. So I need angles in the first and second for this one as well as first and second for this one. Let's see what the directions are. To the nearest minute. We're still to the nearest minute. So we'll do inverse sine of 5/6. Inverse sine of 5 divided by 6, and then we'll DMS it. And that's one we want. 56 degrees, 27 minutes. That'll be one of our first ones. 56 degrees, 27 minutes. Now I got to get in the second quadrant. So second quadrant, we're coming back from 180. So we'll take 180 and subtract off that 56 degrees and DMS it. And you get 123 degrees, 33 minutes, 123 degrees, 33 minutes. All right, now we got to do the 2/3. So we'll do inverse trig sine of 2/3. Oops. DMS it. That's one of our answers. 41 degrees, 49 minutes. 41 degrees, 49 minutes. But we also need to get the one in the second quadrant, and that's taking 180, and we're going to subtract off this, and we'll DMS it right away. And we get 138 degrees, 11 minutes. 138 degrees, 11 minutes. Wow, 4 answers. That was a lot. All right, what do we got next? 15? Now we're going to 17. Oh, notice 17, we're only going to pick angles between 0 and 180, but I can include 180. I can include 180. So let's see. What the... Oh, wait a second. That's okay. They got a GCF. They both have a sine. So I'm going to take out a sine x, and I'm left with 1 plus 2 cosecant x equals 0. That's not a problem. Who cares? So this one is sine x equals 0. And this one here is 1 plus 2 cosecant x equals 0. And you have to solve that. I know I've been skipping the steps on the last few, but let me show you. This one is -1. Divide by 2. Divide by 2. And I get cosecant x equals -1/2. All right. So this one's easy. It's just 0, 180, 360. But if you remember, we're only going between 0 and 180. So in this case, I can just use the ones 0 and 180 degrees. Now, something interesting is going to happen here, and you're going to see this is going to crash on us. And the reason this is going to crash on us, and I'll show you on the calculator what it looks like, because I have to, if I take the reciprocal of this, don't I get, because the reciprocal of cosecant is sine. Sine x equals -2/1. And can sine ever be bigger than 1 or -1? And if you try it on your calculator and you say, okay, I don't believe him, he's full of crap. So we'll go into tangent. And we'll go down to cosecant, -1 divided by 2, and you'll see crash. It doesn't work. So while sine and cosine can't be bigger than 1, cosecant can't be between -1 and 1. All right, not a big deal. That was 17. We got one left, kiddies. One left. GCF. In this case, we got a GCF cosecant. Might be interesting. So cosecant x equals, 2 sine x minus 1 equals 0. So we're going to do cosecant x equals 0 and 2 sine x minus 1 equals 0. This one just gives me sine x equals +1/2. We'll come back and talk about that one. But can cosecant equal 0? Well, we just talked about the fact that cosecant can't be between -1 and +1. It has to be outside of that, because sine runs between +1 and -1. And so therefore, this thing here can't ever happen. And if you tried to take the inverse cosecant of 0, it would crash. Undefined. See, it says undefined. Not going to work. So when does sine equal +1/2? Well, that reference angle is 30 degrees, but sine is positive in the first and the third quadrant. So you need this reference angle. So that would be 150 degrees. So I've done half of them. The other half are yours. And probably what I'm going to do is, I think this is a work day actually, but I got to look. This might be just a work day for us to work all day in. And then I might have assigned something else for homework. But anyway, that's it. That's all she wrote, kids. Welcome to the jungle. Gets worse here every day. We finished it in 22 minutes. Yay, bye.